Welcome back to another video. So in this video we are going to be discussing about the solution for the differential equation of the damped oscillation. So the differential equation of damped oscillation is going to be d square x by dt square plus 2b dx by dt plus omega square into x is equal to 0. Take it as equation number 1. This equation has been derived in a previous video. If you have not checked out, so I will be putting a link in the description box. You can go and verify and you can take the solution for this one. Now, so this type of a differential equation will be solved by taking the solution A, or let me take x is equal to A E alpha t is the solution for the above equation, where alpha and A are constants. If I take the solution as an equation number 2, now I need to differentiate this equation with respect to t. So the solution will be dx by dt is equal to a into exponential. The differentiation will be the exponential and the alpha is the multiplying term with respect to 2. So I will take alpha into e alpha t. Take it as equation number 3. Now, so dx by dt has been formed, so I can replace this term. So I need to replace the first term. So again I need to differentiate this term with respect to t. So dx square by dt square is equal to a into alpha will be alpha square and e into alpha t. Take it as equation number 4. So till now I have found the value of x, which can be replaced by equation number 1, and equation number 3 can be replaced by dx by dt, and equation number 4 can be replaced by the first term dx square by dt square. A into alpha square exponential alpha t plus 2b into a alpha exponential of alpha t and plus the omega square, and the x is taken as a exponential alpha t is equal to 0. In this term I can take a common of a exponential alpha t as a common term. The remaining term inside the bracket will be alpha square plus 2b alpha plus omega square will be the term which will be inside the bracket. Now I have took that equation that a into exponential of alpha t, it can be written as substitution x into alpha square plus 2b alpha plus omega square is equal to 0. By observing this equation, it is looking like similar to the quadratic equation. Either x should be equal to 0 or alpha square plus 2b alpha plus omega square should be equal to 0. So x, it is a displacement can't be 0. So displacement, if it is not getting 0, it is showing that the body is not at oscillation. So I can't take this one as 0. So I need to find the value of alpha. By the quadratic formula, I can clearly say the solution for alpha is equal to minus b less or minus root of b square minus omega. So this solution, so quadratic formula what we have used is x is equal to minus of b plus or minus root of b square minus 4ac divided by 2a. This is the quadratic equation formula which we have used here to solve this solution. So that is the thing which I have applied for this quadratic equation. Alpha square plus 2b into alpha plus omega square is equal to 0. By solving this solution, general solution of the damped oscillation equation can be given by x is equal to c exponential of minus b plus of root b square minus omega square into t plus d into exponential of minus b minus root of b square minus omega square into t. So this equation is the general solution for the equation. So I need to solve this equation by where c and d are constant. So entire solution for the equation is already found, which is general solution. X is equal to c and d. This entire equation is the actual solution, but I need to find the constant value of c and d. Then only the entire equation will be completed. Now what I will do, taking time t is equal to 0 and displacement x is equal to x naught is the initial position where we will going to be taking displacement starting point x naught. If you apply this condition for the above equation, the equation will become c and exponential of t is 0. So anything exponential to the 0 is the value is 1. So I will get a solution c and exponential of another 0 because t is the condition is 0. So c plus d will be equal to x naught. Take it as equation number 1. Now I need to solve this equation by applying some conditions where at a position the velocity where we start initially, then the velocity dx by dt will be always equal to 0. Whenever I will take the position of x naught and the t is the initial position starting, if x tends to maximum position, it should come to the rest position and it should reverse the direction. So at reversing the direction at a peak point, the velocity will become 0 because it should make it it's a 0 and it should reverse the direction. So the velocity of the system is equal to 0 where velocity considered as a 0 dx by dt. So according to this condition, I need to differentiate this term above equation. I will be differentiating dx by dt is equal to exponential b plus root of b square minus omega square, and c is the constant, and the exponential of minus b plus of root b square minus omega square into t. So half part is differentiated and the another half part will be d, and the term is a minus b minus of root of b square minus omega square into exponential of minus b minus of root of b square minus omega square into t. This is the actual solution. Now I know the condition where dx by dt tends to equal to 0. So by checking this equation, and we know that the condition is time at that position is t is equal to 0 where we start. So at that point, if you take these two as a 0, the equation becomes minus b plus root of b square minus omega square into c and plus b into minus b plus root of b square minus omega square. So this is the solution. When you take this term as equal to 0 and this term is 0, this both the remaining solution of this equation will be the above equation. Above equation. Now, if you take the common term minus b, it will be having c plus d and plus it will be having a root of b square minus omega square and the term will be c minus d. Simple transfer of the coefficients into one side and they will be taking a common. Here I can clearly say that c plus d by a previous equation it can be written as minus dx naught plus root of b square minus omega square into c d. If I want the value of c minus d, the equation turns into dx naught divided by root of b square minus omega square. Take that equation number 2. So I know the value c plus d is equal to x naught. Now adding equation 1 and 2. So by adding equation 1 and 2, the 2c value will be equal to x naught 1 plus what will be the value b divided by root of b square minus omega square. So I want the value of c. You take the c value, c will be equal to x naught divided by 2 divided by what will be the value 1 plus b divided by root of b square minus omega square. This is the solution for that. Now c. If I apply the c value in a previous equation where c plus d is equal to x naught, now the value will become 2d is equal to x naught into 1 minus b divided by root of b square minus omega. So the d value will be x naught divided by 2 into 1 minus b into root of b square minus omega square. This is one of the solution. Now, if you apply d and c in a general solution equation, the entire equation x general solution can be given by where the c will be x naught divided by 2. Since the common factor, you take it out and bracket of 1 minus b divided by root of b square minus omega square and the exponential of minus of b plus of root of b square. Since it is a plus, the previous equation was plus, I will take plus omega square into t, and plus I know that d value, since x naught by d is common, we took outside, no problem. So if the remaining terms are 1 minus b divided by root of b square minus omega square exponential of minus of b minus of root b square minus omega square into t. So this equation will represent the solution for the differential equation of